Now, in order to exchange or agree keys with Bob in a secure manner, we need to authenticate Bob in order to securely exchange those keys. If a man is sat in the middle, he might be able to send us a public key pretending to be Bob, or pretending to be Bob's public key when we request it from Bob or when we try to download it from a site. So you can't just take a public key and assume that it is the real key. We need to authenticate that it is the real key first. And this brings us to other cryptographic technologies, and that is hash functions and digital signatures, which help provide authentication or legitimacy of the senders and the receivers. So if you look here, you can see input, you can see the hash algorithm or function, and you can see the output. A hash function takes as input data of any size. So it can be an email, a file, a word. In this case, we've got Fox, and it converts it via this hash function to here, a fixed size string of characters. And these values returned by the hash function are referred to as simply hashes or message digest, or in this case, digest. Now, a very important feature of the hash function is that you can never convert back from this to the original input. This is a one-way hash function, and no keys are required for this. You just require input, the hash function, and then you get the resulting output, which is always of a fixed length depending on the type of function that you're using. So this provides integrity, and it detects unintentional modifications. It does not provide confidentiality, authentication. It cannot detect if an intentional modification has been made. There are many examples of hash functions. You've got MD2, MD4, MD5, Havel, SHA, SHA-1, SHA-256, SHA-384, SHA-512, Tiger, etc. Today, if you're looking at a crypto system, really it should be using SHA-256 or above, which means SHA-384 and SHA-512. Let me show you some examples of this practically being used. Okay, so here we have TrueCrypt, which is a whole disk encryption technology if you're not familiar. And this is the file that you would download. Now, this here is the resulting hash of hashing this file against this algorithm, SHA-256. So when you download this file, you can verify that the file has not been changed, i.e. it has integrity, using this. Now there are tools that you can download to do this. One such tool here is QuickHash. And what I can do is I can choose a file and Chrome, drag it in there, and I can see that that is the hash for Chrome for SHA-1, 256, 512, and you'll notice that as we go up the numbers in the hash algorithm, the hash length gets bigger because that is the bit length. SHA-1 small, 256, 512, and MD5, which is weak and shouldn't be used. So this is used as a way of verifying that what you have downloaded has maintained integrity. Now the clever among you may be thinking, well, what if where I go to download something has been compromised? So here is the Tails website, and we'll discuss Tails more. But say I want to download Tails, and here it is, and I have the hash here of that. But if this website has been compromised, it means that they could change this download and add something to it, a Trojan or some way of tracking me. And you could also change this as well. So that hash provides no value there. It cannot detect intentional modification, we need something else to verify that this site is in fact who it says it is. And this is where we move into certificates, digital signatures, and other methods. Another way you'll see hashes used are with passwords. Now, when you enter a password into a website or into your operating system, it is very, 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 very bad practice for you just to store that password within a database. Because if that database is compromised, then your password is compromised. What should happen is your password is converted via a password key derivation function to a hash. And you can see here we've got examples of the Windows operating system converting the administrator password to a hash. And this is stored in something called the SAM database within Windows. And we'll discuss more on that later and how that can be compromised. But this is just to give you another example of how hashes are used. And another use of hashes is to include a pre-agreed shared secret into the message and then hash that message, which is known as a HMAC, or Hash Message Authentication Code, which provides authentication integrity because we have the pre-shared key and we have the hash used in combination together. Don't worry too much about the detail. It's just another technology used in crypto systems that you don't need to know the absolute ins and outs of.